down to the office? Did you take the pass with you or no? Mystery. Good morning. Oops. Okay. So we learned some basics yesterday. This has been on every Regent so far, so it'll probably be on your midterm. It'll definitely be on your test. Writing a polynomial function. So you're going to be given some roots, and we started this yesterday when we looked at a picture. We were given the roots via the picture, and we wrote the function to a certain extent. Here is kind of the general format, and I'm going to talk about that more in a minute. That's going to be a flashcard for us, but I'll get there in a second. And here's what an example will look like. Determine the equation of a quadratic function whose roots are -3 and 4, and which passes through this point. Okay? So express your answer in standard form. Verify your answer by, okay, we'll get to all there. First things first. We are given the roots, and we did this yesterday. If the root is -3, what's the factor? X plus 3. Bo doesn't miss a beat. Comes in, participating. If the root is -3, the factor is x plus 3. And if the root is 4, what's the factor, Kaylee? M. Good. Now, if you sketch a graph, there's your root at -3. There's your root at 4. They're starting with a quadratic, so this is a parabola. I don't know anything about the a value, do I? Is this opening up or opening down? I don't know. Look up here. Don't draw this because I don't know. This could do this. It could still open up but look a little bit more shallow. Or it could open down. It could open down and be much more steep. I have no idea until I use another point on the line. So here's the general format. It's always y equals, there's some a value that I have to figure out. And that a value will further determine, is it opening up or down, and also how steep it is, right? The bigger the a value, the steeper your parabola. The smaller the a value, the wider your parabola. Yes? That has to do with vertical stretching. The bigger a is, the bigger the vertical stretch. The taller and skinnier we are. Okay? So on top of giving you the roots, that's going to create factors, they also have to give you a point. Now, just based on the location of 2, -50, what quadrant, Micah, is 2, -50 in? Plot the point 2, -50 on your graph. Is it in quadrant 1, 2, 3, or 4? 4. So given that point, which is just some random point, does this parabola open up or down? What do you think? If it opened down, it would be too wide on the outsides to catch that point. It opens up. Opens up. So a quick sketch is going to look something like this. Now you can draw that in. Label this point 2, -50. It's just in that general area. So should we expect our a value to be positive or negative? Positive. We expect it to be positive. Now, that should happen on its own, so let that knowledge for you be a kind of a checking point. How can we use this general structure and use this point to calculate a? If I want to solve for a, what do I need to do, Maggie? Perfect. That's the point x, y. 2 goes in for x, negative 50 goes in for y, and that will allow us to solve for a. So that's negative 50 equals a times 5 times negative 2 once you get that simplified. What's 5 times negative 2? So negative 10a. That's probably the better way of writing it. And to solve for a, we divide both sides by. And so we've found our a value of 5. So I will tell you, when we do this, we haven't done the majority of the work, but it's 95% written. We only have to go back and just replace that now with a 5. So our answer is y equals 5 times x plus 3 times x minus 4. And that's the equation of the quadratic. Now, sometimes we're done. And if it doesn't say otherwise, I would just stop here. This one was very clear, though. Express your answer in standard form. So what do we have to do to this to get it into standard form? Just do a whole bunch of multiplying through. So start with distributing your 5. So that's 5x plus 15. You only multiply your 5 by that first set of parentheses, though, right? It will trickle through to the x minus 4 eventually. Just give it time. And then I FOIL. 5x times x is 5x squared. 5x times negative 4, negative 20x, plus 15x, minus 60, and combine like terms. So final answer, y equals 5x squared. Combine your 2x terms, you get negative 5x minus 60. That's the equation of the parabola. Andrew. Okay, I'm going to get there. So m is multiplicity. It says that. Did I say that? Where m is the multiplicity of each root. Okay? So sometimes they'll say you have a double root at negative 3. And if you had a double root at negative 3, then it would have been x plus 3 is the factor with a little squared after it. So going back to that multiplicity, the bouncing that we talked about, does that make sense? Okay? So here's the flashcard. Polynomial function format. And I'll put this online, so don't worry about it. I'm actually going to clean up this whole thing so it's not as messy. Polynomial function format. And on the back, you need to write y equals a. And then you don't need to write the word root. We can use like r. So x minus, and I'm going to use a subscript of 1. So that's x minus the first root, x minus the second root, so r sub 2, and then dot, dot, dot. But a little m exponent on each of those sets of parentheses for the multiplicity. Okay? If they don't say otherwise, like they didn't in this one, we're going to assume that the multiplicity is just 1. But if they say double root, that's a multiplicity of 2, so you'd use an exponent of 2. If they say triple root, you'd use a 3. Any questions? Okay. Number 2. Here they're giving us the equation right here. Part A, what are the x-intercepts? Write those in. Think about that on your own. Write those in. What are the x-intercepts? And what did you get, Aiden? Very good. So we're just teeing that up. X equals negative 2, positive 5. Now, we're not going to sketch all 3 of these. I'm going to do it on my calculator for you because it's not the sketch that's so important. It's kind of... Can anyone, just without seeing them, think they know what's going to be the connection between this graph versus that graph? Prior to me explaining to you what this is all about? Isaiah? I'm asking you to maybe play teacher a little bit and kind of guess what they're going to be getting at by a changing A value. This one has an A value of 1. That has an A value of 2. That has an A value of 4. Any ideas? As the A value increases, it's going to get wider. What do you think, Maggie? Stretch which way? Vertically. Right? Isn't that multiplier out in front? That's a vertical stretch. So, Isaiah, you were on the right track, but it's just going to, when it stretches vertically, it actually gets taller and skinnier, right? But what do you notice? What are the roots of this one versus the roots of this one versus the roots of this one? They're all the same, so that's kind of maybe funny. So here's a graph of just, oh, I'm still in that crazy window. Hold on. Oh, boy. Hold on. Here is the first one. I don't love that I'm missing the base here, so I'm going to open my window, my y from like negative 20 to 20. I think, is it in there? Okay, good. You lied to me, Cameron. So there's my first graph. Okay, now I'm going to go back to I just did the same one 3 times. I'm going to insert into the second one, insert a 2 as my coefficient. So the second one's going to be 2 times. So watch what happens when that comes up. Here's my first graph with the A of 1. Here's my A of 2. So you see how the roots are still the same, but it got stretched vertically by a factor of 2. So the vertex, wherever it was, is now double the distance down. It's now off our graph. So I'll open up my graph a little bit more. How about negative 100 to 100? That might be too much. So there's my first. There's my second. Taller and skinnier, right? And if I go to my third one and insert a 4 as my A, now it's going to get, here's my first. Here's my second, taller and skinnier, still the same roots. Here's my third, taller and skinnier, still the same roots. Good? And that ties in, obviously, your transformation knowledge about a multiplier out in front, which is a vertical stretch or compression. How about this? What if, those are all stretches, right? Because that number is greater than 1. What if I inserted, I'm going to delete that one altogether, clear it out. What if I inserted a coefficient of 1/4? Right, that's a vertical compression. So here's my original, and then here's my 1/4. Now I'm zoomed out so far that you could barely see that come below. But if I went to my negative 10 to 10 interval, you'll see it a lot more. Here's my original, and here is my wider one. And that's putting 1/4 there. I could put 1/10 there or 1/100th there, and it's going to get super wide because it's super compressed vertically. Good? Flip to the back. Now let's go to exercise 4. Create the equation of a cubic. Cubic means a degree of 3. In standard form is telling me that unfortunately when I finish this I have to multiply it all out. A double zero, a double root, in other words, at negative 2. So y equals a, and what's my factor, Kaylee Smith? If my double zero is at negative 2, what's my factor? X plus 2. And what's my exponent? Since it was a double, multiplicity of 2. And another 0 at 4. Factor x minus 4. Okay? A little different here. They don't tell me a point. Or do they? What do they tell me, Nate? Is at 16. So what point is that? Right, because we all know from our flashcard that the y-intercept is when the x-coordinate is 0, right? So we plug in 0, 16. 0 plus 2 is 2. 2 squared is 4. 0 minus 4 is negative 4. So altogether on the right, that's negative 16a. You on board with that? Divide both sides by negative 16, and our a value is negative 1. So we just plug that in. Negative 1, x plus 2 squared, x minus 4. And multiply that all out. What should you multiply first? This is not going to be great. Andrew? Right here. And hopefully you know some of your shortcuts, so you can just make that x squared plus 4x plus 4, I hope. Then you can multiply negative 1 through the first set of parentheses if you want, or you can multiply and kind of distribute out the trinomial times binomial and save your negative 1 till the end. It's up to you. But we would just simplify that out. That's just basic Algebra 1 multiplication, okay? So hold off on that. I'm not going to finish this one out. I do want to make sure you're visualizing how this does or does not make sense. You had a double 0 at negative 2. That's right there, yes? So it's going to bounce off of that. And another 0 at 4. And a y-intercept at negative, positive 16, which is somewhere up here. Okay? So this has to go that way, right? If we want to catch our y-intercept, that would have had to have done that. Do you agree? Okay? And this one at negative 2 was a double root, so we should be bouncing off of that. Agreed? This last one was a single root, so it went through. Is that end behavior consistent with a cubic odd degree polynomial with a negative a value? Is it? Odd kind of mimics linear. If it's a negative linear, doesn't it start high, end, low? This one starts high, ends low. You see that? Okay. I need to show you something so everything kind of works there is my point. You should have gotten a negative a value. We did get a negative a value, but you should use ideas like that in sketches to confirm that you're correct. And also, once you have it written, you can just type this into your calculator and check it and make sure it looks right. Okay? I have to show you a different notation. It actually came up on one of your tests earlier this year, and in the middle of your test I told you what it meant. But when you see written in symbolic, good, mature math form, end behavior type stuff, this is what it's going to say. As x, and then there's this arrow, and then, does anyone know what this says? As x approaches, that means approaches infinity. So as you go on this graph and your x coordinates are getting bigger and bigger and bigger and bigger and bigger, as x is going towards infinity, what's happening to your y coordinate? It's going down infinitely, right? Towards negative infinity. Does this make sense? Okay, do you remember this test question? Remember me stopping you guys in the middle of the test and explaining it? And then also as x approaches negative infinity, which means essentially as we trace our graph to the left forever and ever, what's happening to the y coordinate? It's going towards positive infinity. Okay? Any questions on that notation? Okay, and back up to exercise 3. Oh, who am I going to pick on? Jake. If I have an x-intercept of negative 4, what's my factor? And what are my other factors? Keep going. Okay, and how do I have to improve this so it looks like the general format? Y equals always an A. Always an A. And then we're going to plug in what, Connor? We covered our x-intercepts. We always plug in the point. What's the point that they gave us? 620. 6 goes in for which letter? Nope. 620 is a point. All points are an x-coordinate first and a y-coordinate second. So 6 goes in for x and 20 goes in for y. Good. And then we would just solve for A from there. How do we feel? Day 2, polynomials under our belt. How'd it go? I think writing it kind of also helps round out your understanding, so I hope that was good info. And corrections are due. I've totally adopted, by the way.